Good afternoon, ladies and gentlemen. Thank you very much for the kind introduction. I'm Nenshad Bardoliwalla. I'm the Chief Product Officer and one of the co-founders of Paxata. And today I'm going to be talking to you about escaping ETL, the journey to information at the speed of thought. Let's go ahead and get started. We've seen some amazing presentations today around all of the innovation that's happening with machine learning and algorithms. I very much like the example of having Google being able to write responses automatically to your email. This helps me a lot with corresponding with my boss. But what we take for granted is that in our personal lives, with our phones, our TVs, our smartwatches, that consumer technology is very, very powerful, and we can ask a question to Siri or to the Google Assistant or to Amazon Alexa and get a response instantaneously to almost any question that we can imagine. This is not true in our business lives. Our business lives actually have information systems that are far more primitive. We have heard, and the dialogue has been continuous for the last 5 years, that we are drowning in data. We have more data than we have ever had before in our lives. We have created most of the world's data in the last 2 years, and this is not slowing down. But we at Paxata believe, and as you heard in many of the presentations today, it is not data that we make decisions on. It is not data that we build models on, but rather it is information that is the critical element that we need to make our decisions on. So we have to ask ourselves the question, what is the difference between data and information? If we look at the types of data that we bring into our environments today, traditionally in the business world, we have brought in data from ERP systems, from CRM systems, from supply chain systems. But in the last 5 or 6 years, you have seen that data now comes in from a variety of new sources, from social media, from consumer websites, from machine data and machine-generated data, such as log files. But that data alone is not sufficient in order to be able to make business decisions. If the data is not complete, if the data is not clean, if the data is not contextually relevant to the problem that I'm trying to solve at the time that I'm trying to solve it, and most importantly, if the data is not consumable for me at the time that I need to consume it, then that data is not information, and it cannot be used to make good business decisions. We have had technologies in the industry for the last 30 years that help to turn data into information. We call these tools ETL tools, or data quality tools, or master data management tools. But they suffer from a number of challenges that have become an important part of the dialogue in our industry over the last 5 to 6 years. Traditional tools for turning data into information, ETL and data quality tools, are typically only for very technical professionals, for people who work in the IT organization. They require many different products to be integrated by the customer in order to be able to do the job of turning data into information. So you may have 3 different tools for data quality, 3 different tools for data integration, and 2 different tools for master data management. All of these tools have not been rethought to take advantage of all of the new algorithms that are now available and that can be run at scale. And so these tools require that you do a lot of manual work, drawing diagrams on your screen in order to instruct the computer what to do, instead of the computer being smart and helping you by telling you what you should do. Most of the traditional tools in this environment were built for data that is from the relational world, which makes sense because for most of the last 30 or 40 years, relational data has been a key source and target for data in the enterprise. And finally, the traditional tooling in this space is built for a scale-up environment where you have to keep buying bigger and bigger servers instead of being able to distribute that workload across many servers. And what is the result of this? As you heard on the panel earlier today, 80% of the time of any analytics project is spent on the process of data preparation, of finding data, of profiling data, of exploring that data, of transforming it and cleaning it, and making it available for your business intelligence tools or your analytic applications and predictive and machine learning models. So the challenge that most businesses have today is that the tools that the IT team has are very good tools. These are tools that you may be familiar with from companies like Informatica or Talend or IBM or Oracle. And the IT folks are able to use those tools, but they do not understand the data. On the other hand, the business people do understand the data, they understand the meaning, they understand the context of where that data should be used, but nobody has taken the time or the initiative to build tools that suit them. And so there is a massive bottleneck in the industry where most of the time people spend cleaning data instead of spending most of the time doing analysis and making good decisions based on that data. And we think there's a way to rethink this problem. When we started Paxata in 2012, we looked at every layer of the analytics stack, from analytic applications to the business intelligence tools, to advanced analytic capabilities, to the enterprise information management tooling. This is where data integration, data quality, and master data management are located. And of course, the data management layer. And we were very, very surprised at what we found. For every traditional tool in the market, very good tools that I have had the honor of working on in my career at companies like SAP, for every one of those tools, there was a corresponding tool that had emerged in the new market in the last 5 to 10 years. So there are new analytic applications like Anaplan, tools like Qlik and Tableau in the business intelligence market are now 50% of the revenue of the overall BI market. In analytic applications, and especially in advanced analytics, you're seeing a revolution and a renaissance with companies like Google and Microsoft and a number of others, H2O, who are building very, very powerful capabilities. And of course, many of you will know that Hadoop and many of the new database technologies like MongoDB or Cassandra have become very, very popular. But what was very curious to us in starting our company in 2012 is that nobody was looking to rethink the problem of how do you acquire data, how do you clean data, how do you integrate data, and make it available for the new tools that are on the market. And when we looked at the market, a lot of the talk that people were talking about in 2012, and in fact, many of the talks today and yesterday have been about a couple of different audiences that are very familiar to us. The first is the data scientist audience. Data scientists have very strong technical skills. They typically work with open source tools like R or Python or Scala. And what we observed, and continues to be true today, is that data scientists, while extremely valuable to an organization, are only a very small part of that organization. If we look at the developers or the data engineers, there are a couple of million of these folks in the world, and they already have a tool set that they can use today in the products from very good companies like Informatica and others. But what we believed at Paxata in 2012 is that the next major revolution would happen when we could bring the capabilities of being able to do data integration and data quality and master data management to the business analysts. These are the people in your organizations today who are doing this work in the most powerful and most frequently used popular product in the world, Microsoft Excel. If you know how to use Microsoft Excel, you probably know about features like being able to create pivot tables or being able to do what's called a VLOOKUP. And what we believed is that we could unlock the capabilities of the hundreds of millions of people who know how to use Microsoft Excel if we could build a product that targeted them instead of just the developers or just the data scientists. And so what we imagined in 2012, and now has become reality 5 years later, is an environment where you could pull data from your cloud-based data sources, whether it be Amazon S3 or Microsoft's WASB storage or Google Cloud Platform. You could pull data from your traditional enterprise sources, your relational databases and your enterprise applications. You could pull data from your data lake, your various different Hadoop distributions, or your local file stores and some of the semi-structured formats that people use. And in a single, interactive, very easy to use way, you could gather data, explore that data, clean it, combine and relate it, shape it, classify it, and ultimately create what we call an answer set, which is the cleansed information that is ready to then be delivered to any of those data sources. So one environment for business analysts to do the work that they need to do, so that instead of spending 80% of the time on cleaning data, maybe they can spend 80% of the time actually working on their algorithms or coming to conclusions. To do this, we have looked at a number of very exciting technologies, which I'll talk about in just a minute. One being the business consumer experience. Many of you will know that when you use technologies like Facebook or Twitter, you do not have to take a training course to use those tools. You're able to use them without any training, and we wanted to use those principles as well. The use of algorithmic intelligence. AI is very, very popular right now in the industry, and we wanted to take a variety of different algorithms and apply them to the data preparation process to make it simple for people to be able to do this type of work. Distributed computing. We made a decision very early on in our life that we would use Apache Spark, which in 2013, very few people had heard of. But we built our technology to allow very large-scale interactive data processing on the Spark platform. And of course, when you build a solution from the ground up, you want to build it in such a way that it can run in any cloud environment, in a multi-tenant fashion, whether it be AWS or Microsoft or any of the cloud environments that you're looking at today. So with that, let's talk about the power of what is available today, right now. We look at a roadmap of 3 phases to getting to the vision of information at the speed of thought. The first phase is the ability to provide people with self-service data preparation tools, easy to use, point-and-click intelligent tools for being able to do their work. So we believe there should be 4 principles that describe this type of capability. One is it needs to be built for analysts, but enabled by IT. Number 2 is that it needs to be unified. We need to bring together all of these capabilities into a single environment. Number 3, we need to be able to work on all types of data and intelligently stitch that data together using algorithms. And number 4 is that we need to allow for flexible deployment options that allow customers to deploy this in any environment they like. So let's look at each one of these individually. What you're seeing on the screen is what the Paxata application looks like. We designed it for business people to be able to use the system. What do business people expect of their systems? They want the system to be point and click. They do not want to write many scripts in order to be able to do their work. They want to be able to interact with the data. Just like with Microsoft Excel, where we can point and click and see a formula update or a set of columns update, we should be able to do the same thing in our data preparation environment. We should be able to work with multiple people in the same context so that if you want to see what I'm doing in the system and I want to see what you're doing, we can both share the same screen and get those updates. So interactive, script-free, point-and-click environment is very important. However, that does not mean you can avoid the governance aspects of such a system, because self-service on its own, without governance, is anarchy. So we believe that the way that you provide governance in these types of environments is that you can record every single step that somebody takes inside of the system. You can record what they did, when they did it, you can annotate those steps, and in fact, you can roll back the clock and look at previous versions of the data and previous versions of the steps so that you can recreate history at any given point in time. So while we believe that flexibility is extremely important, that flexibility has to be combined with the ability to govern the data by recording every step that somebody takes inside of the system. This is business enablement, but with IT support. The second is this notion of unification. Most business people, analysts, developers, or data scientists don't want to use 10 different tools to do their work, but unfortunately, nobody has built a single tool that allows them to do what they need to do. But what we envisioned is that when you needed to do the tasks of integrating data, whether it be appending data sets or pivoting data sets, that you should be able to do that in one fluid environment. We envisioned that if you needed to profile the data, to measure the data quality challenges that you have with that data, and to repair those elements inside of the data, that also needed to be something available in the exact same environment. Enrichment, being able to bring in third-party data or other data sets in an organization, should be something that's very natural and very easy inside such a system. Being able to govern the data, as we mentioned, by recording all the steps, but also seeing the lineage to be able to trace any individual value in the system to understand how it was derived is very important. And lastly, the notion of collaboration, having multiple people work on the data, sharing the data sets that they work with, sharing the project steps that they work with, all in this one environment. So when we think of unification, this means bringing all of these capabilities into one single user experience so that everything that a person needs to do, from sourcing raw data all the way to publishing to a modeling tool or a business intelligence tool, is available inside of this environment. The third thing is one of my most favorite aspects of Paxata, which is the use of algorithms in order to automate the data preparation process. For those of you who work with data on a regular basis, many times, if you want to join two data sets from two different databases, you have to look at the data in front of you and compare each of the individual columns to determine how to join that data together. But what we believed when we started on this journey is that we could use techniques from the search world, like vectorizing data. We could use techniques from the machine learning world and the semantics world to actually observe the data in the data sets and make an inference as to how those data sets could be joined and present that as a recommendation to the user. So in our system, running on top of Apache Spark on very large volumes of data, when you have a single data set, and then you ask Paxata to bring in a second data set, you do not have to determine how to link those data sets together. Paxata's machine learning will figure that out for you and thus automate one of the hardest parts of the data preparation process. And we provide similar algorithmic capabilities for being able to union multiple data sets, as well as to standardize various data sets in the system. So the use of algorithms in order to apply them for the purpose of data preparation is very critical. And finally becomes the flexibility of the platform. Many of you are just getting started on your journey to work with Hadoop and Spark and some of these technologies. What we believe is that a true enterprise-class system will have multiple layers inside of its architecture to allow for the types of scenarios that customers are looking at. In our case, we provide not only a user experience that's very easy to use, that you saw pictures of, but also RESTful APIs so that the entire platform can be run in an automated way using programmatic techniques. We provide a middle tier which has a lot of our application logic, but really where a lot of the special capabilities of this architecture come is what has been built on top of Apache Spark. We have taken many of the techniques of the columnar database world from great companies like Vertica and Greenplum, many of which have been acquired, and taken those columnar techniques and brought them into the Spark world for data preparation. So it is possible in a system like ours to take hundreds of millions of rows of data and hundreds of columns of data and interact with that data and prepare it without having to run batch processing. And this can run directly on top of your existing Spark and HDFS environments, along with providing connectivity to a variety of different data sources, systems management capability for running the architecture, and of course the security that enterprises expect with capabilities like single sign-on using SAML and LDAP and Active Directory support. But where it gets really fascinating is that the systems that are built today are built for a cloud-based environment. And in a cloud-based environment, especially for use cases like data preparation, having a static cluster no longer makes any sense. So instead, a different way of thinking about the problem is to have different tiers of processing with a minimum for high availability. So that's depicted by the 3 nodes in brown. Then you can add additional capacity. In our case, when we run our cloud environment in Amazon Web Services, we are able to run the system with additional resources by paying for additional reserved instance nodes. Those are depicted in the darker green. But then there come the use cases when a data scientist says, I would like to prepare or process 300 million rows of data right now. And that is where the traditional architecture fails, because there is no simple way with traditional tools to just scale up and add a huge amount of capacity. But in an elastic architecture like ours, we are able to very rapidly provision hundreds of Spark workers, have them join the cluster for a small period of time, run the processing on hundreds of millions of rows, and then finally, when the work is done, we can shut off the extra Spark clusters, and thus we only pay, and our customers only pay, for the capacity that we need to use. So this is bringing variable cost economics into the world of data preparation in a way that has not been accomplished before. And all of the capabilities that I described and the technology I described is available today with the current offering that we have. And in fact, through our exclusive relationship with our partner Ashisuto, who is here with the booth in the back of the room, you can see many of these innovations for yourself. But the question you might be asking is, where does this go from here? How do we evolve this technology in the future? If you found this subject interesting, I'd like to share some of the customers that have worked with Paxata over the last 5 years to bring this vision to reality. Our customers are many of the top banks in the world, including banks in the Asia-Pacific region. We also, because of our presence in Silicon Valley in the United States, we work with companies like Cisco and Intel and Yahoo. Many of the top brands, most recently McDonald's became one of our customers. I believe McDonald's is popular in Japan. We also work with a number of healthcare customers like Bristol Myers Squibb, Vizient, and Healthcare IQ. And so we are just at the start of a new revolution where business people can change the equation and work with raw data and on the fly transform that data into information in such a way that they no longer have to spend 80% of their time doing data preparation, but now they can spend 80% of their time building models, building visualizations, and getting to analytically driven decisions, which is really why we do what we do in the first place. So I'd just like to say that I appreciate the opportunity to speak with all of you today. You can see this technology in action with me if you have questions, or our close partner, Ashisuto, who is our master distributor here in Japan. And I thank you very much for the opportunity to speak with you today. And I hope you enjoy the rest of today's conference. Thank you.